Hello everyone, here is the project report for course EE5135 Digital Communications. My name is Lichen and my partner is Yilin. The topic we chose was 5G. We combined the content of the course and the extracurricular research and ultimately chose the direction of 5G and smart cities for research and investigation. Today, we will discuss the combination of 5G and smart cities in the order of these chapters. I will start with the background and development significance of smart cities, and then introduce the definition, characteristics, and development process of 5G networks, and then introduce the composition, architecture, and planning strategies of 5G networks in smart cities. Then my partner will introduce the technical implementation of 5G network and focus on in-depth research on physical layer technology, combining with the content learned this semester to explore its application in smart cities. Finally, consider the future development trends and possible challenges of 5G networks. First of all, as we all know, we currently live in a world of cities. Just like this picture, looking down on our planet and is like a dense web of spiders, where humans are in a process of rapid urbanization. The development of urbanization has the following characteristics. First, urban development and industrialization promote each other, and the scale of cities is expanding rapidly. Changes in urban industrial structure and the urban form mainly focus on gathering towards the central city. However, the rapid urbanization development has brought many problems, like population congestion, traffic congestion, and environmental pollution. We need to do our best to solve these problems based on the current level of technological development. As early as 2008, the IBM Corporation of the US proposed the concept of smart Earth, which is to make full use of information technology and internet technology in various industries, from the Internet of Things through the internet and sensors, and then apply cloud computing and supercomputers to make human life and work more intelligent. The emergence of 5G, like a catalyst for the integration of these technologies and smart cities, has solved many of the challenges of technology implementation from the fundamental issue of communication, providing better public services and achieving the goal of green development. So, let me introduce what 5G is. Like previous 1G, 2G, 3G, and 4G technologies, 5G is the forefront of cellular mobile communication technology. The 5G, the fifth generation mobile communication technology, which is 5G, is a new generation of broadband mobile communication technology with characteristics of high speed, low latency, and large connectivity. 5G communication facilities as network infrastructure for achieving human-machine and object interconnection. The International Telecommunication Union, which is ITU, has defined three major categories of 5G application scenarios, namely enhanced mobile broadband, which is EMBB, and ultra high reliable low delay communication is URLLC, and massive machine class communication, which is MTC. Enhanced mobile broadband is mainly aimed at the explosive growth of mobile internet traffic, providing mobile internet users with a more extreme application experience. And the URLLC is mainly aimed at vertical industry applications such as industrial control, telemedicine, and autonomous driving, which have high requirements for time delay and reliability. And MTC is mainly aimed at applications targeting sensing and data collection, such as smart cities, smart homes, and environmental monitoring. So the development process of 5G and the smart cities can be divided into the following stages. First is 2000 and from 2008 and 2013 is the initial exploration stage. At this stage, academia and the industry have begun to pay attention to the research of 5G. At the same time, the concept of smart cities has gradually become a research hotspot. And then the maturity and standardization of technology took place in 2013 to 2019. In 2013, the ITU launched the IMT 2020 plan, which aims to establish technical standards for 5G networks. And in 2016, the 3GPP began to develop a new 5G wireless access technology standard, namely 5G New Radio. And last, the commercialization and the application expansion, which from 2019 to present. In 2019, multiple countries and regions around the world began deploying 5G commercial networks, which are more closely linked to the development trend of smart cities. From this picture, we can see that currently there are more than 600 smart cities in the world and that have begun to take shape. As one of the most developed countries in Asia, Singapore has launched a smart city construction plan as early as this century, focusing on transportation, medical care, education, and other aspects. Singapore emphasizes the concept of citizen-centered construction services and requires that it truly benefit citizens. Taking transportation construction as an example, in addition to ordinary bus queries, Singapore provides personalized new functions such as displaying the congestion status of each path. From the perspective of logical functions, the smart city communication network structure is a three-layer network structure, which namely sensoring network and aggregation network and a wireless access network. Sensing network are networks formed by various sensor nodes. According to the deployment status of nodes, sensing network can be further divided into static sensing networks such as smart home, environmental monitoring, and other application files, and dynamic awareness networks such as body area network and the Internet of Vehicles and some so on. The converged network, which is an aggregation network, is composed of multiple mobile terminals, with the gradual popularization of intelligent terminals, and in addition to completing the traditional services of cellular mobile communication networks. It can also serve as a relay node in the remote data transmission process of the sensing network, providing the data access for the lower layer sensing network, so that sensing data can be sent to the smart application platform through the wireless access network on the upper layer of the aggregation network. Next, I want to introduce the 5G planning strategy for smart cities. First is constructing sponge communication network. Simply put, it is a reasonable planning of network capacity configuration. Although the network capacity of 5G mobile communication networks has greatly improved compared to 4G networks, the requirements for network capacity in smart cities will continue to increase. Once sudden demand occurs in a certain area, 5G mobile communication networks may still face the problem of insufficient network capacity. Different physical layer algorithms need to be designed in different scenarios. And second, based on urban planning and reasonable planning of network partitions. 5G networks have the characteristics of being three-dimensional and so they cannot be planned entirely in accordance with the decentralized mode of 4G networks. Instead, it is necessary to fully integrate the requirements of smart cities for network mobility and establish multi-level three-dimensional network systems around the multiple network cores and centers to achieve full coverage of 5G networks. So that's all of my part for today's presentation. Thank you for listening. And next, my partner Liu Yilin will introduce the technical implementation of 5G, especially the physical layer protocol.
Yep, this is my part, and I will start from wireless transmission technologies. The first one, massive MIMO technology. In summary, massive MIMO is the beam assignment of many antennas with advanced antenna technologies on mobile device and network base stations. Wireless signals can be clustered in a specific direction instead of being spread over a wide area. Using these technologies with the help of feedback from the mobile terminal, the beam can find any point in space. As a result, users can connect to the network with the aggregated beam whether they are on the street or moving between floors of a building. Of course, it has many advantages, and the first one is that the different beams have their own very small focus areas, and the users is always in the best signal areas within the small area. And the second one is as independent narrow beam can be formed for different users in the coverage space. The antenna systems can transmit data from different users at the same time, which can increase the system's throughput by tens of times and increase the network capacity. Yeah, and the third one is that the antenna beam is very narrow and provides precise coverage for users, and the interference to color areas can therefore be greatly reduced. And the last advantage is that the freedom of the beam in both horizontal and vertical directions provide flexibility and performance benefits in terms of continuous coverage. And the second one is full duplex. Full duplex allows two-way information transmission between two devices at the same time. For mobile communication must use full duplex, it must avoid major interference between uplink and downlink service. The current mainstream full duplex methods for mobile communications are divided into two methods, distinguished by time or frequency corresponding to the TDD and FDD methods. Yeah, from these pictures we can see that FDD, as simple as it is to understand, means that the uplink and the downlink service are isolated in two frequency bands without interfering with each other. And the TDD means that the uplink and downlink service use the same frequency band, but it uses time separation to transmit to and receive signals. It uses a half duplex transmission to simulate a full duplex transmission process. Yeah. And there is a question that which is better, TDD or FDD? Each one has its own advantages and disadvantages. For TDD, we must divide it two frequency bands for uplinks and downlinks. And these uplink and downlink bands must be symmetrical. On the other hand, the number of the time points allocated to downlinks and uplinks under TDD is not fixed. It is more flexible. This is one of the key reasons why 5G favors TDD, because the main way to increase rates in 5G is to increase bandwidth. However, TDD is not as good as FDD in terms of rate, mainly because under TDD, as downlinks and uplink service are only differentiated by time, this results in a certain amount of time being left between downlink and uplink time points to avoid interference between uplink and downlink. There is no data transmission during the rotational interval, and leaving it completely idle and therefore losing data transmission rate. And the next part, I will introduce the two networks. It is wireless networks technologies. And the first one is software-defined wireless networks. It is SDN. And it is a very new technology derived from the internet. And in SDN, the control plane is separated from the hardware of the network device, creating centralized control with the network device completing data forwarding based only on commands from the central controller, and enabling operators to better control the networks, simplify network management, and better innovate service. And another one is self-organization network technologies, is SON. It was developed by the operators of the NGMN, Next Generation Mobile Networks, and it enables operators to operate and maintain their networks efficiently, while meeting customers' demand and sustaining their own goals. The idea is to bring self-organization capacities to the network, including self-configuration and self-optimization and self-healing, to automate all aspects of network planning, deployment, maintenance, application, and troubleshooting, minimize human intervention. SON are now becoming a mandatory feature of new network rollouts and are showing significant benefits. Okay, and the next part will be the most important of the whole presentation, and it is physical layer technologies for 5G networks. And the first technology is FOFDM. Firstly, we all know that 4G uses a very powerful technology, OFDM. It is very powerful because the use of OFDM allows radio waves carrying data from different users to be transmitted overlapping in frequency without interfering with each other, greatly improving the efficiency of frequency utilization in mobile communication systems. Whether it is the traditional FDM or the OFDM used in 4 and 5G, radio waves will leak like waves at both end sides, and the strength of the leakage signal is weaker and further away from the central frequency. So the different signals need to be isolated for a distance so that the impact of leakage is reduced to the extent that it doesn't interfere with the transmission of other wireless systems. In 4G networks, the isolation zone takes up 10% of the bandwidth allocated to the operator, which means that 10% of the frequency resources are wasted. In 5G, however, the signal leakage is greatly improved using a more advanced technology, that is FOFDM, and the frequency band occupied by the isolated band is reduced to 2 to 3%, and which means that the data transmission rate can be increased by around 8% through the improvement of OFDM. So let's see the block diagram in the slide right. The FOFDM system divides the system frequency band into multiple sub-bands with different parameters to support different service requirements. But the core of each subband is still conventional OFDM. In addition to splitting the subbands, the new system also adds subband filter to each subband to change the high out-of-band radiation of previous OFDM systems to efficiently reduce interference between different subbands. And the next technology is millimeter wave. From this picture, we can see that millimeter waves are waves whose frequency range from approximately 30 GHz to 300 GHz. According to communication principles, the maximal signal bandwidth for wireless communication is approximately 5% of the carrier frequency. So the higher the carrier frequency, the greater the achievable signal bandwidth. Therefore, by using the millimeter wave band, the spectrum bandwidth is easily doubled by a factor of 10, and the transmission rate can be increased significantly. So we can see that there is an equation. It is Fisher's transmission equation. It is very famous in the communication. It means that the received power is the proportional to the wavelength, which means that the shorter wavelength of millimeter waves also means higher transmission losses. It means that the less received power. Not only that, but the penetration of other capabilities of millimeter waves are also significantly reduced. So, the use of millimeter waves brings a wider bandwidth. It also suffers from transmission loss. So, it is imperative to find ways to increase the received signal to noise rate without significantly increasing the transmitter power. The combination of millimeter wave and MIMO technology solves this problem. In millimeter wave communication system, the beam management function refers to the management of the narrow beam formed after beam assignment. Beam scanning is generally divided into raw scanning and extra scanning, which take place on the control channel and the data channel respectively. The beam measurement process plays a key role in both the side access state and the connected state. Many major signals such as SSB, CSIRS, and SRS. When a beam failure is detected by the UE, the stream failure recovery process is happened. The access request is restarted and the data transmission resumes. And the last part of the whole presentation is my summary, and I will give some suggestions to the topic. In conclusion, The increasing level of 5G technology is a technological tool for building smart cities, which can bring various social and economic benefits to promote the good development of smart cities and enhance the degree of wisdom. It is also necessary to pay attention to the direction and the storage of smart cities in the future, and I will give some suggestions. And the first one is we should promote the sharing and the integrating of the data. Of course, we also need to pay more attention to the prevention and control of the security risks. Okay, that's all for the whole presentation, and thanks for listening.